Up until now, we were dealing with frequencies, and we were basically treating all words more or less equally. But the words are not equal, right? So you know that some words carry a lot of content in them, other words don't. So the words like aardvark, cryogenic, or jacquard, they're all very topical. As soon as you see cryogenic, you pretty much know what this bit of text is going to be talking about, right? It's a very strongly content-bearing word. Other words like said, went, big, they give you no idea about what the topic of the text could be, right? So the word said, it could be a scientific article, it could be a description of a movie, it could be a tweet, it could be anything. Right? So how do we make some words more important than others? We'd like to make those words, cryogenic, aardvark, we'd like to make them more important than said in our similarity function. And the idea is to give more weight to words that occur rarely, because these words, they carry the content, but they're also the kind of words that you don't expect to see very often. So one simple intuition about which words could be meaningful words and which words are not is to look at the overall frequency of a word in a large body of language. So if we have a word that occurs everywhere in every tweet, that's possibly not very a useful word. If you have a word that is mentioned once, it's a typo. If you have a word that's mentioned 3 or 4 or 5 times, it's probably a very, very specific word. Right? It's not a typo because it gets repeated, but it's probably a very useful, very discriminating word, and we'd like to give a lot of weight to it. So one way to give a lot of weight to those infrequent words is through a measure called inverse document frequency, or IDF. And the way you do that is you count the number of different documents that contain a word. So it's not the overall frequency. You could use the overall frequency. It's called the collection frequency, but usually you use the document frequency, the number of different documents that contain the word. And you basically take the inverse of df over c, where c is the total number of documents in the collection. So if you take this part, df over c, that's one way to think of it as the probability that a randomly picked document contains the word w. So it'll be a small number for rare words, it'll be a large number for words like said or the. Okay? So what we do is we take 1 over that, c over the document frequency, and then we take a log of that. Okay? And I'll explain the log in a couple of seconds. Right. So if we take that factor, then what we can do is we can insert it into our ranking formula, right? So our ranking formula from the previous slide was the frequency of the word in the query times the frequency of the word in the document divided by the length of the document, and now we're going to multiply this whole thing by that IDF factor. That's a weight. That's going to be a big number for rare words, content-bearing words, and a small number for very, very frequent words. So this part is usually called the TF component, this part is the IDF component, and overall we still have our dot product, right? It's just this becomes the weight of the word W in the document, and this part becomes the weight of the word W in the query. And note, I'm not using IDF twice. Right? So I'm multiplying the document component, I'm not multiplying the query component. The reason I'm not doing that is they're the same thing, right? It's the same word. The term frequency is different, because here you're talking about how many times W occurs in Q, how many times W occurs in D. But it's the same W. So it would be the same IDF component in both places, you just end up squaring it, and empirically it turns out that squaring it isn't a terribly useful thing to do. Okay, so now, why are we doing the log? One of the ways, one way to think about the importance of the log, why it's a log and not just a thing by itself. The range of possible values that this quantity can take is a lot higher than the range of term frequencies. Think about why is that. Right? So if you're Google, what is C? 10 billion? Big number. Right? And what possible values can DF have?
As low as 1.
Yes, it can be as low as 1. How high can it go? 10 billion. So the word "the," for example, occurs in just about everything out there that is well-formed English. So the range for df over c is anywhere, the range for c over df is anywhere between 1 and a billion. The range for the term frequency is usually in the single digits. Right? So you have one number that has relatively small range and another number that has huge range. If you multiply together those two numbers, the huge number will completely swamp the smaller numbers. Right? So IDF will have a dominant effect in the formula. So by taking the log of that, you're basically squashing the huge range. A billion becomes what? 30. Yes. So you're basically putting TF and IDF on the same scale by using the logs. Now, so that by itself is a pretty good similarity function. We are going to make it better, but before we do it, let's look at the effect that the IDF has. What was the question?
Which log?
Which log? Very good question. You should be able to convince yourself, or actually, you know what? Why don't you answer that question? So if I take log of 2 versus log of 10, what is the difference going to be? It's rank invariant. Exactly. So it doesn't matter what log you put in there, because converting from one base log to another, it's just a constant that comes out of the summation. Again, it affects the values of the scores, but it's not going to affect the ranking. So it makes no difference. Usually what do we use? Usually just use natural logs just because they're sort of universal, but you can use anything really. It doesn't make a difference.